Welcome back to my channel. Today I'm here with new topic SQL basics. You can see it on the slide. In previous videos we have seen what is artificial intelligence, machine learning types, prompt engineering, RAG and AI agents, and even quantum computing basics also. Yeah, today I'm here with new topic SQL. So before we jump into serious stuff like SQL, I wanted to share one quote that I read this morning. Do not compare your page 1 with someone else's page 100. Everyone is unique and each person has their own journey, pace, and strengths. What you see in others is often the result of years of effort and experience. Instead of comparing, focus on discovering your own potential. Everyone has something special within them. There just needs to be a moment, a decision, or an effort to unleash it. Believe in yourself, stay consistent, and keep moving forward. Your time will come when you work on becoming the best version of yourself. Actually, I started learning SQL earlier, but lost focus and didn't continue with the technical skills like SQL, Python, and data visualization tools like Power BI and Tableau. Now I realized that SQL is not optional. It's a fundamental bread and butter skill in this field. If I had understood this earlier, I would have been more consistent, but it's okay. What matters now is that I have recognized its importance and I am ready to work on it seriously. Lastly, it is never too late to learn something new. So, this is the motivation I wanted to follow. Okay, let's get started. SQL, one of the most powerful and most in demand skill in the entire tech industry. And the best part, you do not need any prior programming experience or knowledge. If you can write a sentence in a plain English, you can write SQL query. Okay, SQL stands for Structured Query Language. Uh, is the standard language used to communicate with databases to store, retrieve, update, and delete data. It is the backbone of almost every application, website, and business in the world. So, in recent Stack Overflow survey, SQL was the most commonly used language in data-related jobs, even more than Python. Companies like Amazon, Flipkart, Infosys, TCS, every startup in every city are actively looking for people who know SQL. So yeah, by this end of this video, you will know all SQL fundamentals. I hope this video is 100% beginner friendly. No math, no complex theory, just practical SQL that you can start using right away. Let's go. So what exactly is SQL and why you should learn it, right? So it is a language was designed specifically to talk to relational databases. It was invented in the 1970s at IBM, and since then it has become the universal standard for working with data. Almost every company in the world stores its data in relational database, and SQL is how you access that data. Here are the 4 strong reasons to learn SQL right now. Reason 1, it is the most in-demand skill. SQL appears in more job listings like Python, uh, more than, in fact, Python, R, or Tableau. Whether you want to become a data analyst, data scientist, software developer, business analyst, or a product manager, SQL is non-negotiable. Reason 2, the salary is excellent, great salary. In India, a junior SQL developer or a data analyst earns between 6 and 12 lakhs per year. Senior data professionals with strong SQL skills earn 20 to 30 LPA. In the United States, in the US, data analysts with SQL skills earns between 70,000 and 1,30,000 dollars per year. Reason 3, SQL is used absolutely everywhere. Every mobile app, every business system uses a database. If you understand SQL, you understand how data flows through every technology product in the world. Reason 4, it is genuinely easy to learn. SQL was designed to read like plain English. The command to retrieve data literally says select and then what you want from where it is. It is the most intuitive programming language. Okay. Databases where data lives. Before we write any SQL, let us understand what a database actually is. A database is simply an organized collection of data stored in a way that makes it easy to access, manage, and update. Think of it like a digital filing cabinet. Instead of paper files in racks, you have tablet tables, not tablets, tables of data on a computer. And instead of opening racks to find a file, you write a SQL query. Okay, there are two main types of databases: SQL databases and no SQL databases. SQL databases are relational. SQL databases stores data in tables just like an Excel spreadsheet with rows and columns. Each table has a fixed structure. Tables can be linked to each other through keys. This is what makes them relational. The most popular SQL databases are MySQL, which is free, open source, used by Facebook, Twitter, and millions of websites. PostgreSQL, which is extremely powerful and widely used in enterprise applications. SQLite, which is lightweight and used inside mobile apps. Microsoft SQL Server, used by large corporations. And Oracle Database, used by banks and financial institutions. NoSQL databases, non-relational. NoSQL databases are more flexible. They store data as documents, key value pairs, or graphs. Examples include MongoDB, Redis, Firebase, and Amazon DynamoDB. They are great for unstructured data and apps that need to scale rapidly. The key point for today, the SQL databases are the foundation of most traditional business applications, and SQL is the language you must learn first. Once you know SQL, understanding NoSQL becomes much easier. Okay. So SQL data types, what kind of data can you store? Before we start creating tables and writing queries, we need to understand SQL data types. Because when you create a table column, you must tell the database what kind of data will go in it. There are four main categories of SQL data types. Category 1, numbers. Use int for all numbers like a student's ID number or an age. Use decimal when you need precise decimal values like product price such as 499.99 or 19.99. Use float for approximate decimals like temperature reading. Category 2. Text. Use varchar when the text length varies, like a person's name or an email address. You specify the maximum length. For example, varchar 100 means up to 100 characters. It will allow use text for large blocks of text like product description or blog post. Use char when you know the exact length, like a state code. Only two characters, right? For example, Andhra Pradesh AP or Maharashtra MH. Category 3, date and time. Date stores just the date, like year format and month format and date format. Time stores just the time. Date time stores both date and time together. Timestamp is similar but automatically adjusts for time zones. Very useful for apps with global users. Category 4, others. Boolean stores true or false, useful for things like is this user active or inactive, or is this order delivered. Null represents the absence of value, it means no data was provided. And enum lets you define a fixed set of allowed values like active, inactive, pending. That's it. Those three values categories it will allow. And all right, let us now start writing. Try to explore real SQL. So we begin with DDL, which stands for Data Definition Language. So we are defining the table structure, guys. These are the commands that define the structure of your database, how your table are built. So the create table command creates a new table. Let me walk you through the example on this slide. Okay. So we are creating table called student. So create table, table name student. Inside the parenthesis, we define each column and its data type. The first column is ID. It is an int and it is primary key, which means it uniquely identifies every student. So no students can have the same ID. Then we have name as varchar of 100 characters. So names up to 100 characters long. Age is an int. Grade is character, one character, since grades are single letters like A, B, C. And email, again varchar of 150 characters. So this is all it takes to create table. Simple, readable, and powerful. Okay. Altering table. So what if you create a table and later realized you forgot a column? No problem. You use alter table to add a new column. For phone number, you write alter table students, add phone. Varchar 15, the table now has a new column for phone numbers without losing any existing data. So drop and truncate. Drop table completely removes the table and the data and the structure are gone permanently. So be very careful with this. Truncate table removes all the data inside the table but keeps the table structure. Think of drop as demolishing a building. Truncate as emptying the building but keeping the walls. Key constraints. Constraints are rules you set on your columns to ensure data quality. The most important ones are primary key, uniquely identifies each row. Foreign key, uniquely identifies links one table to another, create relationships. Not null, must have a value. So the column must always have a value. Unique, no two rows can have the same value in this column. Default, provides a fallback value if none is given. And check, validates that a value meets a condition, like check. So let's say age greater than equal to 0. DML commands. So now we have created our table structure. Let us put some data into it. This is where DML comes in, data manipulation language. These are the commands that deal with the actual data inside your tables. So the insert commands adds new rows to your table. So the syntax is insert into the table name is student. So name, then in parenthesis, column names like ID, name, is values. So we are giving the column names, attributes, then we are providing the values, how many rows we wanted to insert. So modifying existing data. So the update command modifies existing rows. You write update, the table name, set the column to its new role, then where to specify which rows to change. For example, update student set grade equals A plus, where name equals Priya Sharma. This changes only Priya's grade. You can also update multiple columns at once. Update students set grade equals A is equal 21, where ID equal to 1. Okay. Removing data. The delete command removes rows from your table. For example, delete from students where ID equal to 3. This removes only student with ID equal to 3. So now I want to pause, give you the most important warning in all of SQL. If you write delete from students without a where clause, remember, uh, without a where clause, it will delete every single row in the table. The entire table becomes empty instantly. No undo, no confirmation, just gone. So this mistake caused major incident at real companies. Always include a where clause with delete and update. Always. So in 2020, an engineer at a startup accidentally ran a delete from users without a where clause. So that is in the production database during a routine maintenance task. They lost all 50,000 user records. Now that company does daily backups and requires a two-person approval for all delete operations. Okay, now we are moving to DQL. Select. So commonly you will use more than other select. Okay. This is how you retrieve data from a database. Every data analyst, every developer, every business intelligence professional uses select hundred of times a day. Let me explain anatomy of a select statement. So it starts with select, obviously. Then you list columns you want. If you want all columns, you can add star symbol, select star from table name. So you get everything from that particular table. So yeah, you can give some conditions like order by, and you can limit to control how many rows come back. Okay. So let me show you how, like, to get every student from students table. Select star crema from student. The star means give me all columns for all rows. To get only names and grades, select name, grade from students. Now the result only shows two columns instead of all of them. Right? Yeah. So next, moving to where clause. So the where clause is how you filter data. It is one of most powerful features of SQL. Let me walk you through all the operators you can use in where clause. Okay. The equal sign gives a exact matches where city equal to Hyderabad. The not equal operator written as equal to less than or greater than gives you everything that does not match. where grade equal to, right, F. And greater than and less than. So if you want to get the values greater than 50,000 salary and age less than 18, so where class, this is where class comes to the picture. So very clean and readable. And in command, it is lets you match against a list of values where city in Hyderabad, Bangalore, Mumbai, you can all three cities put it in a bracket, so you get all information for only these cities. So this gets customers from any of those three cities. It is much shorter than writing three separate or like or conditions, right? Like, so like is for pattern making, very useful for searching if you do not know the exact column name. So the percent symbol means any character. So where name like RA percentage matches Ravi, Ramesh, Ram, Rakesh, anything starting with RA. The underscore symbol matches exactly one character. Where name like underscore AVI matches Ravi, Davi, Kavi, yeah, so on. So null. Is null finds rows where a column has no value, where phone number is null. This finds customers who did not provide a phone number, very useful for data cleaning. Okay. And or operator combines multiple conditions. And means both conditions must be true, or means at least one must be true. For example, where a is greater than 18 and grade equal to A, find student who are over 18 and have a grade, both conditions must be satisfied. Okay. Order by, group by, having. So now let us cover three more very important clauses. Like I said, order by, group by, having. Order by shorts your query results. Write order by, then the column name, then ascending for ascending or descending for descending. For example, select name salary from employees, order by salary descending. This shows employees from highest to lowest salary, isn't it? You can sort by multiple columns, order by department, ascending, salary, descending. So it first sorts alphabetically by department and within each department from highest to lowest. Group by, summarizing category. So very important, group by. It's not only in SQL, you will see it on the Power BI and Excel, Power Pivot, everywhere. Group by is must, guys. In groups, yeah, it groups your rows by a specific column and then lets you calculate summaries statistics for each group. For example, select department, count in parenthesis star as total underscore employees from employees, group by department. This counts how many employees are in each department. The result shows one row per department with the count. Another example, select department, total salary as total salary from employees group by department. This shows the total salary cost of each department. So group by used everywhere in business reporting, like I said earlier. Total sales by region, average rating by product category, number of orders by month. Yeah. Having filtering groups, having filters the results after grouping, similar to where, but for groupings. This is one of the most commonly confused concepts in SQL. So let me be very clear. Where filters individual rows before grouping, having filters groups after grouping. You cannot use aggregate functions like count or sum in a where clause. You must use having. For example, select department count in parenthesis star as total from employees group by department having all count greater than 5. This shows only departments that have more than 5 employees. The having filters out small departments after grouping. This is very common SQL interview question at companies like Amazon, Flipkart, and what is the difference between where and having? Okay, so for example, select product category average rating as average rating from products group by product category having average rating greater than 4 order by average rating descending shows product categories with an average rating above 4 sorted from best to worst. Yeah, I know. We are discussing, very theory wise. So in upcoming videos, we will try to write, the actual queries. But I wanted to uh, discuss in theory wise so that we can, in upcoming videos, we can write actual. So SQL has 5 built-in aggregated functions that perform calculation across multiple rows and return a single result. These are essential for any kind of data analysis. Count. This counts the number of rows. So select count star from orders, select count distinct city from customers. Gives you the total number of orders. So select count distinct uh, gives you the number of unique cities, right? So including nulls also, or count of specific column skips nulls. Okay. Number two, sum. This adds up all the values in a numeric column, gives you the total salary spent in the IT department. Select some salary from employees where department equal to IT. Number three, average. This calculates the average. Select average price from product where category equal to phone, and min function, max function. Yeah, these are all very important aggregated function. I would say quite important. Yeah, moving to uh, important, another important, in all SQL joins. We have now arrived at one of the most important and most tested topics in all of SQL joins. Joins are what makes relational databases so powerful. They'll let you combine data from two or more tables into a single result. In real databases, data is spread across many tables. You might have a customer table, an orders table, and a products table, each storing different information. A join lets you bring them together. Let me explain the 4 types of joins using our students and exams example. Inner join returns only the rows that having a matching value in both tables. If a student has no exam record, that are excluded. If an exam has no matching student, it is excluded. Only the intersection, the overlap comes through. So the on class specifies so let me read the inner join query. Select student name is score from students as inner join exam E on student ID equal to uh, table dot student ID. Okay. So the on class specifies how the table connect. In this case, the student's id must match the student id in the exams table. Okay. Left join. So left join returns all rows from left table plus any matching rows from the right table. If there is no match at the right, the column from right table are filled with null. So if a student has not taken any exam yet, they still appear in the result, but their score column will be null. Okay, so here select student name is score from students. As instead of inner join, we are going to put left join here. Rest all everything, I would say it is same. Yes, in fact it is same, just we are replacing join instead of inner join here, left join instead of left join here, right join. Yeah. Okay, rest all everything is same. So right join is the mirror of left join. All rows from right table come through and nulls fills in. There is no match on the left. Full outer join returns all rows from both tables with nulls wherever there is no match. In practice, inner join and left join are used about 90% of the time. So joins are the number one SQL topic in technical interviews at every major company. Understand inner join and left join deeply. So, and practicing them, that alone will put you ahead of most candidates. Subqueries and alias. So, yeah, subqueries, in other words, nested queries. A query inside another query used when you need the result of one query as input for another. Very powerful feature in SQL. So a subquery is simply a query inside another query. You wrap it parenthesis and use it as input for the outer query. For example, select name from student where score greater than, then open parenthesis, select average score from student, closing parenthesis. This finds all students who scored above the class average without needing to first find the average separately. Okay. So an alias is just like a nickname. Given with the as keyword, you can alias a column, select salary name 12 as annual salary. So instead of a salary, you wanted to have a column name annual salary for our better understanding or for our representation of the data. Okay, so real projects, online store databases. So we are going to look at the SQL behind an online store database, something like Flipkart or Amazon. And I'm going to show the one of the kind of queries real data analysts write every day. First, finding the top 5 best selling products. We join the order items table to the products table, use sum to count qualities, group by product name, order by total sold in descending order, and a limit to 5 in one query. We have our best seller list. So this is one of the techniques, one of the most important queries that we all use in real world projects. So finding customer who have never placed an order, a left join from customers to orders where to order id is null. The customer has never ordered, perfect for marketing campaign to bring them back. Okay. Yeah, this one. And total revenue. So these are the real queries. So, okay, the real data analyst at real companies, right? Not theoretical, actual business value from actual SQL. So this is what you are going to see or learning. Okay, so another average order value by city, select and round average. So it is kind of nested queries as average order value from orders table. So we are going to join and equal to city ID, and again we are grouping by, then ordering average city in descending order. So tools to practice SQL. And before we wrap up, so wanted to talk on every tool here. Okay, so SQLiteonline.com. So run SQL instantly in your browser, no installation, perfect for beginners. Support SQLite syntax. So PostgreSQL, industry standard open source database. So you can download it and use it. So used by major companies. MySQL Workbench, visual tools for MySQL, C tables, run queries, design schemas, most used in Indian companies. HackerRank SQL. 500 plus SQL challenges from easy to hard. Get certification recognized by employees worldwide. Lead code SQL. SQL problems asked in real interviews at Google, Amazon, Flipkart. Best for job preparation. Google BigQuery. So this is booming, guys. Cloud SQL on Google's infrastructure. Free tier available. Used by data analysts at top companies. So let me give you a lightning fast summary of everything we covered today. SQL is the standard language for relational databases. Every app and website uses one. MySQL, PostgreSQL, SQLite are most popular ones. Then we discussed about DDL commands and DML commands. DDL create, alter, drop, define your table structure. DML commands insert, update, delete, manage your data. Always use where with update and delete. So select and we're filtering. Okay, select is most used command. Combine it where to filter, order by to sort, and limit to control results, or group by. Group by with aggregated functions. Count, sum, average, min, max lets you analyze data at a scale. Having filters groups after aggregation. Joins are the most powerful feature. They combine data from multiple tables. Inner join for matching rows only, left join for all rows from left table. Master this and you are ready for any SQL interview. Yep. So, and that is SQL basics, guys. I'm so proud of you making it to the end. You now understand how databases work, how to create tables, how to query data, how to use joins, and how to deal real data analyst with SQL. So try to explore tools like SQLiteonline.com, create a simple student table, and write you like first select query and practice makes like we are now permanent. And SQL is skill you only truly learn by doing. Okay, only learn by doing. You will only learn by doing. Okay, I'm repeating. Yeah. So if this video is helpful, please give it a thumbs up. So yeah, thank you so much for watching. Okay, I will see you in the next video. Bye.